This is the third video pertaining to the demand curve, and now we're going to look at the price elasticity of demand, which measures consumers' responsiveness to changes in the price of some good or service. So starting off with a question, suppose you manage a toll bridge, you're currently charging $5 per car to cross your bridge. At that rate, 500 cars cross per hour, and you're thinking about raising the price to $6. You want to increase the toll to $6, and you want to have some idea how many cars will cross at the new price. Price elasticity of demand helps us calculate that. We'll come back to this question at the end of this video. Second question is, if you want to increase your revenue, supposing you have a cash flow problem, you need to increase revenue, should you raise the price of your toll in order to do that? If you raise the price, we know that consumers will buy fewer items. The question is, will they buy enough to offset the increase in price or not? And again, price elasticity of demand helps us to answer this question. So we'll come back to both of these questions in the next two videos. When we look at price elasticity of demand, what we're doing is measuring how responsive consumers are to a change in price. And that's done by looking at the percentage change in the quantity demanded of some good divided by the percentage change in the price of that good. And we'll look at the calculations in this video. Because a demand curve, price and quantity along a demand curve move in opposite directions. As the price rises, consumers buy fewer items. When the price falls, they buy more items. Then we're going to say that elasticity will always be a negative number because it will always be an inverse relationship between price and quantity. So we're going to use the absolute value of elasticity, and when the absolute value is greater than 1, then we say a good is elastic in demand. In other words, the percentage change in quantity demanded exceeds the percentage change in price. Consumers are pretty responsive to that good. You can think of something like a box of Cheerios. The price goes up 10%, quantity demanded would decrease, say, 20%. That would be elastic in demand. When elasticity is less than 1, or we say the absolute value is less than 1, then the good or service is inelastic in demand. Cigarettes, for example, are inelastic in demand. The price could increase 20%, and the quantity demanded would decrease by just 5%, so therefore it's minus 0.25 would be the elasticity of demand for, say, cigarettes. And the last thing we'll look at is what we call unit elastic. When elasticity is equal to 1, or absolute value of minus 1, then we say the good is elastic in demand, and that's going to have a special reference to revenue when we get to that. When we look at elasticity of demand, we want to understand the determinants of elasticity. What makes people responsive to a change in price more for one good more so than another? And the first thing we'll look at is available substitutes. When there are a lot of substitutes for a good or service, then we say it's going to be elastic in demand. Raise your price and people will move on to another substitute. Plenty of substitutes for a box of Cheerios. There are other cereals or other breakfast foods, so there are a lot of substitutes for Cheerios, but there aren't a lot of substitutes for cigarettes. Your next best alternative is quitting, and that can be difficult for some people. Second thing we want to look at is the percentage of the budget that the item consumes. So if we're talking about, say, a box of salt, that price can go from $1 to $2, a 100% increase in price, and you're really not going to cut back on your use of salt. The decrease in your consumption isn't warranted by this change in price because it doesn't take up a large percentage of your budget. However, if the rent on your apartment or home, the mortgage on your home goes up by 100%, then that's going to be a huge percentage of your budget, and you're going to respond pretty quickly by either getting a smaller home or smaller place, bringing in roommates. That will be more inelastic in demand. That'll be more elastic in demand because of the higher price of the house. Whereas salt will be inelastic in demand because that's such a small percentage of your budget. You're not going to be that responsive to a change in price. And the last is the length of time that a price change is in effect. Change is pretty costly when you make quick changes, therefore we change over time. If the price of gasoline goes up from, say, $2 to $3, we're not going to make abrupt changes and not drive by a more fuel-efficient car, start carpooling, walking, riding a bike. We're not going to do those those changes immediately. However, over time, we do start making those changes, and our demand becomes more elastic over the long run. Something like cigarettes. If the price of cigarettes increases by 50%, I may not quit smoking right away. What I will do is over time, though, I'll find some way of ceasing my smoking habit. Now, one thing on that example, I have heard from somebody who worked in retail sales with cigarettes, and what they found was when a price change increased, when the tax increased on cigarettes, people immediately stopped smoking. Sales went down abruptly, but they couldn't stop the smoking. They picked it up again. You went right back to normal within a few months. So I use the example of cigarettes for the length of time. However, that actually may be a poor example because I could see what this person was explaining. Price goes up, I immediately decide I'm going to quit smoking, but it's hard to sustain that. I pick up a pack of cigarettes again a few weeks later, and sales go right back to where they were. But gasoline is probably a better example. As the length of time increases, people make better changes. We're going to look at two ways of measuring elasticity of demand. The first is the point elasticity of demand. This takes a specific point on the demand curve, Q1 and P1, and it tells us how people are going to respond from that point. So we look at that by the old quantity, the new quantity minus the old quantity divided by the old quantity, divide that by the new price minus the old price divided by the old price. And that gives us a percentage change in quantity divided by the percentage change in price. We may want to look at what's called arc elasticity, and this tells us within a range of prices what the midpoint is. So if we're looking between two different prices, this will tell us what that midpoint is. And this one is going to be the new price minus the old price divided by the new price plus the old price. All of that divided by, the new quantity minus the old quantity divided by the new quantity plus the old quantity. Divide all that by the new price minus the old price divided by the new price plus the old price. And so we can look at these with a couple of calculations and questions. Suppose Max has a hamburger joint. They sell 800 hamburger plates per day when the price is $8 per plate. And if they raise the price to $9, they sell only 600 hamburger plates per day. Calculate the price elasticity of demand, the point price elasticity of demand for hamburger plates sold by Max. Go ahead and pause the video and calculate the point price elasticity of demand for this problem. Okay, the new quantity is 600. The old quantity is 800, so 600 minus 800 divided by 800. Divide that by the new price minus the old price divided by the old price. 9 minus 8 divided by 8. So the percentage change in quantity demanded is minus 25%. Consumers responded to this $1 increase in price by decreasing consumption 25%. That $1 increase in price represented a 12.5% increase in the price of Max hamburgers. So we say the percentage change in quantity demanded was minus 0.25 or minus 25% divided by a 12.5% increase or 0.125 increase in price, and that gives us an elasticity of demand of minus 2, which again we said is elastic in demand. Calculating for arc elasticity of demand. Suppose Jen has a lawn service. She mows 1,000 lawns per month when the price is $40 per lawn, but when she raises her price to $60 per month, sales go down to 600 lawns per month. Calculate the arc price elasticity of demand for Jen's lawn service between $40 and $60. Again, pause the video and we'll come back to an answer. Okay, looking at this one again, we want to look at the new quantity minus the old quantity divided by the new quantity plus the old quantity. Divide all that by the new price minus the old price divided by the new price plus the old price. And what we have is a minus 25% decrease in the lawns mowed given the 20% increase in price going from between 40 and 60. And this tells us that the arc price elasticity of demand for Jen's lawn service is minus 1.25, which again, that is elastic in demand. So let's go back to our introductory question about the toll bridge. When you were pricing the toll at $5, 500 cars crossed in 1 hour. How many people would cross in 1 hour if you raised the price to $6 and you knew that the elasticity of demand within that range is minus 1.2? So again, let's do the point price elasticity of demand to calculate this answer. All right, so when the price is originally $5 and you raise the price to $6, quantity goes from 500 to we don't know what it is, And if the elasticity of demand is minus 1.2, we can set up our equation, new quantity minus old quantity divided by old quantity. Well, we don't have the new quantity yet, that's what we want to calculate, but we do have the new price and the old price, so we can see that that's going to be 0.2. 6 minus 5 is 1, divided by 5 is 0.2. Multiply minus 1.2 by 0.2, that gives us minus 0.24. And now we can solve for x, and we can find that the people crossing the bridge will decrease from 500 to 380 as the price goes from $5 to $6 per bridge. Next, we're going to look at movement along, where along the demand curve elasticity changes, and look at a few more things with elasticity. This is the end of this video. We'll move on to, again, the next one with elasticity.